Let's look at some basic calculus fundamentals. So these are just techniques how to solve these type of equations. I'll get into some in-depth explanation what they are in another video. So you might be tempted to substitute 1 into the equation, but when we do that, we get 0 as a denominator, right? And then what happens is that this function is undefined. But that wouldn't be the case, because we can factor the numerator of this function. Or we can say x plus 1, x minus 1. Perfect difference in squares over x minus 1. Now since we have product, which is just multiplication, as a numerator, we can now simplify by cancelling out the like terms, and we are left with x plus 1. Now we can substitute the 1, and that becomes 1 plus 1, which is then equal to 2. What about b? B is a bit tricky, because now you have the same function but just opposite way around. So what will I do now? I'm going to follow the same process of simplifying. I have x minus 1 over difference in squares, x plus 1. And now I can simplify, so I'm then left with 1 over x plus 1, which will then give me, if I substitute infinity into the equation, I have infinity plus 1. That gives me 1 over infinity, which is then equal to 0. Well, why is it equal to 0? Because let's say we take 1 over 2. This is moving from 1 to 0, since it would be 0.5. What about if I say 1 over 10? Well, this gives me 0.1. What if I say 1 over 100? Well, this gives me 0.01. And I can continue going forever, 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 forever. And what will I get then? Well, eventually, this value will become so tiny that we would eventually reach 0. Okay, let's go over to some basic derivatives. Now, there's a cool little method you can use to solving derivatives, where it is n x n minus 1. So what this means is, let's say we have x raised to the third power. All I do is I move the exponent, multiply it with the coefficient of x, and subtract 1 from the exponent. So the derivative of x cubed would be 3x squared. So let's find the derivative of x squared. Well, the derivative of x squared would be the second, or the second power multiplies with the coefficient. Remember, there's an invisible 1. So that becomes 2x, 2 minus 1, gives me raised to the first power. But I don't need to write this. What about b? B is a little bit more tricky, because here we need to follow some exponential rules. Well, one of our rules are that we can flip this from a denominator to a numerator, but giving it a negative exponent. Now I can follow the same principle. Move to the front and subtract 1. That gives me negative 1x raised to the negative second power. Now I can take this back and flip it from a numerator to a denominator to change my exponent from negative to positive. So I'm left with x squared.